So for our poster, we're looking at the effect of different watershed properties on the PFAS levels in fish. So just to kind of introduce what PFAS are, they're known as pre- and polyfluoroalkane substances, which are compounds that are typically used in a variety of different commercial and industrial applications. And these things eventually find their way into the environment where they tend to persist and they will bioaccumulate in fish and other aquatic life. And this is relevant because we as humans eat fish and some of these other aquatic living organisms, and we become exposed to these PFAS primarily through dietary ingestion. And recent research has found that exposure to these chemicals can increase the risk of certain cancers like prostate, kidney, and testicular. It can also decrease fertility. It can cause developmental delay in children and increase hormonal interference. Fish found in watersheds with differing geographical locations and varying stream properties may contain different levels of PFAS, and that's what we're looking to investigate with this project.
For our materials and methods, our statistical sample was comprised of 50 individual fish caught in rivers around the US. Each individual replicate was selected using the following criteria. We selected from a river within the US with a stream order that was a minimum of 5 and a maximum of 10, and from a setting deemed urban or non-urban. Our total number of square kilometers of high infiltration soil and square kilometers of high intensity developed soil was associated with each watershed, and that was collected using Model My Watershed. The PFAS levels in fish were collected from the EPA, and SPSS was used to run all of our statistical tests as seen in Table 1. For a histogram, we displayed the developed square kilometers of high intensity soil. For a frequency table, we looked at the stream order. For our t-test, we compared urban versus non-urban high infiltration square kilometer soils. And for our ANOVA, we compared the region of states and the amount of developed high intensity square kilometers.
Okay, and in table 2, we have it showing the frequency distribution of stream order, and the mode for the stream order was 5, while the anti-mode was 9. And in figure 1, which shows a histogram of high intensity development that is measured in kilometers squared, and the frequency is just numbers. And the mean high intensity development was 19.98 kilometers squared, plus or minus 4.59 kilometers squared, and the range was 137.72 kilometers squared. And then back in table 2, which I forgot to mention, the mean for the stream order was 6.44 plus or minus 0.2.
So in figure 2, that shows the results of our t-test. So in the t-test, we ran urban versus non-urban for our independent variable, and for our dependent variable, it was the mean high infiltration. And what we found there was that there was no significant difference between the means of high infiltration soil in urban and non-urban settings, and that had a t-score of 0.616. So they were not significantly different between those two settings.
Figure 3 displays the results of our ANOVA. We compared the mean developed high intensity square kilometers among 4 regions: the Midwest, Northeast, Southwest, and Southeast. We found that there was no significant difference in the areas of high developed intensity soil, with an F value of 0.773.
All right, so conclusions that we can pull from this data based on what we generated through SPSS was that mean high infiltration soil likely does not affect the amount of PFAS that accumulate in the fish populations.
Another thing that we could potentially draw from this is that the difference in area of high intensity development between regions may have an ecological significance despite the absence of a statistical difference in the ANOVA test. So if you look at the Northeast, it's significantly higher than the Southwest. So even though we didn't find a statistical difference, we may still be able to observe certain ecological effects of having more high intensity development. And one of those effects could be the increased PFAS levels in fish.
Future research could be conducted for correlation between PFAs and other environmental factors.